Okay, so let's talk about now that we know, okay, like the last example, they would do a poll of 1,200 American adults. Well, how do we make sure that 1,200 American adults, how do we pick them? So that's called sampling method. So we're going to talk about all of the sampling methods. This is a huge table and it looks really overwhelming, but we're going to go through it really slowly. So simple random sample, and you're going to see that sometimes called an SRS. This is used a lot. So it's where every member of the population has an equal probability of being chosen. So for example, we could identify all likely voters in the state by putting all of their names in a piece of paper and toss the slips into an obviously very large hat and draw 1,000 slips out of the hat. That would be a simple random sample. What would have been much easier is making a spreadsheet, putting everyone's names in that spreadsheet that are voters in the state, and then you can use what's called a random number generator to choose people. Stratified sampling. So this is where a population is divided into a number of subgroups or strata. So random samples are then taken from each subgroup. It's often desirable to make the sample sizes proportional to the size of each subgroup in the population. So if we think about this in the Gallup poll for 1,200 American adults to determine how many hours Americans look at a screen all day, one way to do that would be to create subgroups based on age, because they could maybe look at 20 to 30-year-olds, 30 to 40-year-olds, 40 to 50-year-olds, 60 to 70-year-olds, because each of those subgroups are going to have some different data that comes out. Another example, suppose that data from voter registrations in the state indicated that the electorate was comprised of 39% Democrats, 37% Republicans, and 24% independents. In a sample of 1,000 people, then you would take out what you would want to make sure you're choosing for your subgroups. 39% of those 1,000 people need to be Democrats. So you would expect to get about 390 Democrats. 37% of those people out of 1,000 should be Republicans. So you'd expect to get about 370 Republicans, and 24% should be independents. So you would expect about 240 independents. So to accomplish that, they would take everyone that's a voter that's a Democrat voter and choose 390 people from there. Everyone that is a Republican voter, choose 370 people from there. And everyone that has no party affiliation and is an independent, choose 240 people from there. Another type of sampling is called a systematic sampling, and that's where every nth number of the population is selected to be in the sample. The starting position is often chosen at random. This is used a ton in manufacturing, where if you have, maybe some objects coming out of a machine and you want to check them for quality control, you can't check every single one, but you could check every third product that's coming out of the machine or every 10th product that's coming out of the machine. So that would be called systematic sampling. So to select a systematic sample, Portland Community College could use their database to select a random student from the first 100 student ID numbers. Then they would select every 100th student ID number after that. Systematic sampling is not as random as a simple random sample. If your ID number is right next to your friends because you applied at the same time, you wouldn't both end up in the same sample. But it can yield acceptable samples. This method can be useful for people waiting in lines, parts of a manufacturing line, or plants in a row. So maybe there was a bunch of people waiting in a line for Apple and someone wanted to figure out, okay, what are you here for? What's the product that most people are here for? Instead of going through, maybe there's 1,000 people in line and asking every single one of those people, they could ask every 5th person, what are you here for? So that would be stratified sampling, and then they would use that data to say for the whole population. Convenient sampling is when samples are chosen by selecting whoever is convenient. This ends up being the worst type of sampling because it doesn't use randomness. And you're going to actually, sadly, this is used a lot when people are trying to manipulate data. So for example, if someone was just standing on a street corner and interviews the first 100 people who agree to speak to them, that is a convenient sample. So this is really convenient to the researcher, but that doesn't necessarily mean that you're getting a good idea of the whole population, because the only people that will talk to you are the people that are willing to talk to you, not necessarily the whole population. So let's look at some different examples to determine the type of sampling method that's described. A court TV determines public opinion on a certain court case by collecting information from a voluntary phone call. So this is a voluntary phone call. So this means this would be a convenient sample because it's not done randomly. It's just people that choose to actually call into the poll. A computer randomly selects 500 students from a college's active student database to predict attendance for at least 100 or at least one home football game. So it's randomly selecting, so this would be a simple random sample. And again, shorthand, we write this as SRS. Every 100th urban rebounder trampoline is given a durability test. So they're checking every 100th trampoline. So that's systematic sampling. A study of daily TV streaming habits uses 100 participants who completed high school only, 100 participants who have a 2- or 4-year college degree only, and 100 participants who have a graduate college degree. So this is pulling from subgroups of the population. So we're doing different subgroups where we have the high school only, 2- to 4-year college degree only, and graduate college degree only. So this would be called a stratified sampling.